So this is a fake data set that I made up. It's based off of one of the predetermined ones in R. But when you have your data, you want to have it laid out like this. Different things that you want to do in R require your data to be laid out in different ways. So you want to have your columns with kind of in long format. So each one of these would be like an individual fish. So in this example data set, we have, I think, 150 fish from 3 different sites. So there was an upstream, a middle stream, and a lower stream. And maybe there's a chemical plant at one of those places. And so what you did is you gathered the fish, you measured their fork length, you cut them open, and you measured their liver weight, the length of their dorsal fin for whatever reason, and you took a fillet and you measured the mercury content. So basically every fish, every row is a line of a fish, and that's what the data looks like. Make sure that you save your data as a CSV, and if you're working with data that has multiple tabs, like in whatever way, just know that CSVs will only save the first tab, so just keep that in mind. This is what R looks like, and it's got several different windows. I can go over more detail if you guys want, what each of these do and how to make your R look a little bit different, but we'll begin as if you haven't started anything in R before. So if you have that script file saved from the Google Drive, one way you can open it is just going into your file explorer and double clicking on it, and it should open automatically in RStudio. But if you don't have it, just go to File and open File, and then just locate it wherever it's saved in your directories. So PCA tutorial. Perfect. So up here is the console. This you can type in code of whatever you want. It'll return it immediately. But the kind of annoying thing is that it won't save, so you'll have to copy it every time you want to make a change. So that's why you want to work with scripts primarily. This is kind of like your work area. And hopefully everyone was able to install the packages that we'll be using. We'll be using several ones that go over ggplot, another couple for ggplot that just support it, and a couple that are related to doing colors. So you just type those in. There's a message.
Yeah, David, it's giving me an error with installing some of the packages like Viridis and Ggsave.
Okay, so yeah, these, I should clarify, these are what you use to call. So in R, when you want to do things, you can do them in base R without using any packages, or you can use these things that they're known as packages. Basically, these are what people have developed to do specific things. And if you're just typing in library ggplot and you haven't actually installed it, then it won't work. So to install, you move over to this window and over to the Packages tab, click on Install, and there you should be able to type in ggplot2 and all the other ones you may need. And it'll take a few minutes to install them. But once they're installed, you can double check by just going into your library over here. These are all the packages that I have installed on my computer. I don't know what the majority of them do. They came installed with R, but if you go down, you can see here's ggplot. And this library function on line 5 here and to 10, that just calls it in. So it tells R that you want to load it in. So you have to install it first, and then once you're going to be using it in your specific project, then you would load it in. Another way to do this is just going in and clicking them, but I find it easier if you just type it in like library, because then you see which ones you're going to be using. So to quickly enter in a code line, you just hit Control Enter, and that'll load in ggplot2 and ggfortify, our color Brewer, Wes Anderson, Viridis, and ggrepel. Okay, are there any questions on that first step?
I got an error saying sorry, question mark box plot, question mark history.
Are you using the this code, the script that box plot?
I didn't type in all of them. I just typed in the first line, and I did install it already.
I'm not really sure what that means. The box plot error. Did you get that error when you typed in you were trying to run one of these libraries?
Yes, yeah.
And you installed them already?
Yes.
Do you know which one it is specifically that's giving you an error?
Yeah, I typed in the ggplot2.
ggplot2.
Maybe I should find it in my packages and try to check mark it.
Yeah, try that.
If I don't see it there, but I did install it, does that mean I didn't install correctly, maybe?
Probably. If you don't see it in your packages, then you haven't installed it yet.
Okay, got it. Thank you.
No problem. Okay, so after you have your packages installed, the next thing you want to do is you want to set your working directory. And this is how R works. Basically, you have your folder, like I said, to set up before, and everything that you get your data from, and everything that you're going to save it to is going to be in that folder. So one way that you can go through it is in the File tab on this bottom right one. You can navigate to it. It's probably going to crash my R because it doesn't work for me. Yeah, so before when I started to use R, maybe I have to reinstall it or something, but this doesn't work for me. It's very simple to just go in and click where your actual file folder directory is. But I have a workaround, and that's just setting your working directory. So you just type in this code. You can use this little tilde symbol here just to not have to type in everything beforehand. But I have a main folder for all my graduate school stuff, and I just made a subfolder for the PCA tutorial. This is going to be different for you, depending on where you have your folder set up. But you need to have some working directory set. And just as an example, if you were to navigate to your folder in this tab, the last thing that you'd have to do is click this little gear that says More and click Set as Working Directory. So this just set my document folder as my working directory, but I'm going to instead change that to where I have the tutorial set up. So, and I'll just show you, this is my PCA tutorial. So again, this is where my data file is, and everything that I save is going to save to this file or this folder. Okay, so let's take a look at our data. We want to load it in, and we can do that by using the read.csv command. And you can name it whatever you want. I just named mine as fish data. Just use it something simple that you can remember, and you'll be typing it a lot, so keep that in mind. And you have two ways of looking at it. You can do the head command, which just gives you the first 6 lines of the code. And this is a nice way just to see that everything looks okay and everything loaded in fine. Another way is if you go to the top right, this is where all of your data files will be, all of your strings, all your vectors, all your variables that you save. They'll be up here for quick access. You can click on it, and it'll pop up just a little quick view. This is just a table view. It's not like Excel. You can't modify anything. It's just for you to view it. But at least you can see what things look like here. Everything looks fine. So we're going to start off by making a PCA in base R. So it's not going to look very pretty. To do that, we have to get rid of this column here, the location column, because when you do a PCA in R, in base R, you can only do it with numeric values. And when it sees things like upstream, downstream, it doesn't know what to do with it because it's characters and it doesn't fit into a PCA. So we'll just move that this row or this column into the row names, just with this command here. And then we'll delete that by using the null command. I can explain these more, like these things in more detail if you want to know like the syntax and stuff. I'm not an expert, but I can try my best. And again, we'll just use the head command just to see what everything looks like. And everything looks good. We see now that upstream is in the rows. And if we wanted to double check that again, we now see that the location column is gone and it's been since moved into the rows. So that's good. Now that we've done that, we can apply the principal components function. And this is just using our data. Another thing I'll just show you really quickly if we wanted to. So when you're defining a variable, you type out what the variable name is going to be. And you use this little arrow with the less than sign and a dash and your function. So we're going to use prcomp, that stands for principal components. And the open bracket, it usually gives you more information. But if you look right there in the little beige, it shows you your X, and that just refers to your data. If you're ever unsure of what a function does, you can type in a question mark and type prcomp, and it should give us the help information. So that's really handy. This just pops up the help tab, and you can always search with the search bar there if you want to do it that way. So we'll get our principal components, and that looks good. So it's given us a list of a bunch of data. we don't need to worry about that too much. Now that we have our principal components, we can just plot this. So yay, we've done a PCA in R, but it doesn't look that good, so we're going to edit this a little bit and make it look better. If you also wanted to, for just the purposes of using a scree plot to look at the components, there's a very simple command to pull up a scree plot. So now that we're doing that in base R, let's go back and let's try things out in ggplot. If you wanted to just make a very simple, quick and dirty ggplot plot of whatever it is that you're working with, you can use the autoplot function. And autoplot, see if I loaded this in right. Yeah, there we go. Okay, so here is the autoplot function. Super simple. It'll make a ggplot really quick and easy for you. So you see that we have our principal components, as we saw, and it's also given our axes the amount of variation that each component explains, which is nice and handy. But again, this isn't very informative. It doesn't show us the locations, so we're going to tweak things a little bit more. You can follow this tutorial that I've linked to as well. It goes into way more depth about the autoplot function. If you like its simplicity, or if you want to read up on it more, that website does a way better tutorial than I could probably give you. And I'm not too familiar with the autoplot. I'm used to doing things step-by-step manually, so that's what I'll show you how to do today. So to work with ggplot, we have to convert our data from this list format, this list format with a bunch of information in it, to a data frame. And a data frame is basically just like what this is that we worked with before. It's all of our data in a frame format of a table. So we'll do that by using this command to convert it as a data frame. And if we want to just check what PCA2 looks like, it looks good. We have all of our principal components and everything looks nice. All the way down, yeah, 150 of our samples. Again, we can use the head function just to view that quickly. And really simple, we can just throw that into a ggplot command. Oh, I lied, I skipped something. We're going to add in the location. So with base R, we didn't want those location values because those location values don't fit into that principal components function. So with ggplot, we're going to throw them back in there. And yeah, now we see that that location column is back in. So we just referred back to our original data frame and we threw them in, and everything is good now, as ggplot uses those to define the different groups. When we break down the ggplot command, you always have to open up the bracket with ggplot and start off with where the data is coming from. So we're pulling the data from our PCA underscore fish2. And again, that just has all of our principal components in it. And it uses what's called an aesthetics. So this aesthetics function is where you're going to define your x values, your x-axis and your y-axis. And you can also add in some other things like labels and color. So when we define color as a location, it's using that location column as a way to divide up what's going to be which color. So upstream is one color, midstream is another color, and downstream is another color. So those just gave us 3 default colors. And you can also adjust this plot window to be bigger or smaller as you please. So I'll just make that a little bit bigger for us. And the other thing too is that this is just a very ggplot on its own. This won't give you anything. It's going to give you a blank because ggplot uses different functions in addition to that base ggplot to give you either line segments or box plots or violin plots, or in our case point plots. So we just add in the geom_point command, and that pops out all of our scatter points. So that's great. If you're happy with this, then that's totally fine, but we're going to go into just a bit more detail now, fixing up the theme and the colors and how things look. So there's a couple of built-in themes with ggplot. We have the black and white theme, which looks pretty good, but again, we still have those grid lines, and usually we don't want those. So we could try out the classic theme, and that gets rid of those, which is nice. And they have a couple other ones like the dark theme. So if you're ever curious how I found these out, all you can do is just make sure that you add that plus to add on to this ggplot and type in theme underscore, and it should pop up with a list of different types of ones. So these are all built in, and they all have different purposes, and they explain everything in that little beige box there. And once you have that, just pop it in and Control Enter, and there you go. We can also edit the background elements manually. So what I like to do is I like to get rid of those grid lines manually myself. And that also leaves me with a nice black box around my plot, which I just like how it looks. And that's just using different commands like panel background. We want it to be white, and we want the fill, like the lines of it, to be black and solid line types. You can make it dashed, I think. Yeah, so of course, if you want it to look like that, you could have it dashed. And then we're going to get rid of the grid major, the grid minor. We'll make those blank, and that's what it looks like. We can also move forward with the text options. So we can change the title of the x-axis, the title of the y-axis, the text of the x. So that's like the grid points, as well as just getting rid of any like legend titles or adjusting the sizes of them. We use the element text to edit the size. So size will change the size, face, make it bold or italic, whatever you want it to be. But you know, if you're going to be playing around with your code a lot, this takes up a lot of lines and it looks a little bit messy when you have it over and over again. So we can define this group of theme information as a variable, like what we did with our data as PCA fish. So again, just using that arrow, it'll define it super simple for us. And now we have that theme information, and every time we call it as just my theme, that's what we saved it as, it'll do all that work for us, and we have that nice looking theme without all the extra lines of code. So it's just a nice way to clean up your code a little bit. It's not absolutely necessary. Are there any questions on this bit of GGA stuff before we move, ggplot stuff before we move on to the colors?
Not really. It's nice how you have everything annotated, like in the script. Like that makes it super, super. Like I can go back and like learn it and stuff too.
Yeah, it makes it really easy when you're sharing code. You can just, if the people annotate it nicely, then it makes it super simple. So I try and do that.
Yeah, totally. I think you did. So that's awesome. Thanks.
Cool. Okay, so we'll go into some colors really quick. There's the R color Brewer package, which is really nice because it provides all of these different types of color palettes. This command just shows all the ones that are available. The nice thing too about this is that it also shows all the colorblind friendly ones. So I would stick to these color palettes if you're going to be using these in publications and presentations, just because you want to be as inclusive as possible. And it's really simple to just pick a color palette that's colorblind friendly. So let's just look at some of these color palettes in our ggplot. So we have dark, which gives us darker looking plots. Spectral, which gives us, oh, sorry, I lied. This is the blues. I should probably fix that. So those are two examples. Just one thing that I want to note too when you're looking at these. In our case where we have 3 points, it's going to take them from the leftmost, so this tealy color, the rightmost, this gray, and one of the middle colors. So that's why our dark 2 color palette looked like that. Of course, if you have more points, it'll use up more of the color options. So that's just one thing to keep in mind. You can also just make it gray if you want. There's a color scale gray function, which is really easy. Some journals may prefer this. And you can also tweak this. So if you look really carefully, downstream is the dark gray and upstream is the light gray. But by changing the values of the start and end in the scale color gray function, we've now flipped it. So downstream is the light color and upstream is the darker color. So you can flip that to however you want it to be. There's also some designated packages that people have developed. So the Wes Anderson package, that's a package devoted to the color themes of the Wes Anderson movies. So if we call that package, when we look at all the different names, these are all the different types of color palettes available from the different movies. So like Darjeeling, I think, what's the other one? Grand Budapest Hotel, that's another one. So if we take a look at what that looks like, now we have the colors sort of themed from the Grand Budapest Hotel. So if that's what you want to look for in your figures, if you want to like throw a nod to the different colors or you enjoy what they look like, you can by all means use those. It's just another option for you. There's also the Viridis package, which is really nice when you have more continuous data or if you have like a scale of information that you want to give color to. This is really nice because they're all colorblind friendly and they look nice. So we have the Viridis main colors. It goes from yellow to a teal color with purple in there. It's a nice looking one. as well as plasma, and there's also another one, magma. So I think I laid out the options for you there. But what I like to do primarily is define my colors manually. It just gives me the most options, and I think it's just the best suited. You don't have to rely on different themes and palettes. You can just pick whatever colors you want. So in this case, I just type them in. You have to use the values command, and when you have a list like this in R, see how there's 3 separate items, hot pink, royal blue, and orange. They're separated by commas. So we have to use this little C thing to let it know that it's a string. If we didn't have that, it wouldn't work. So it gives us an error that there's an unexpected comma just by not including that C. So you can type in hot pink, royal blue, red, black, blue, any colors that you can think of that are pretty standard. Or you can also use hex codes. That's mostly what I do because the syntax for hot pink, like it's a bit restrictive. So using hex codes is the best, I think. If we just did, I don't know, that's a hex code, hex color. I don't know if that's a proper color or not, but that's another way to do that.
You don't need a package for the hex code color inputs, right? Yeah.
That's right. Hex codes is just built into base R.
Yeah, and there's like a link that you might even find out online that has like a list of hex codes that you can use. So yeah, it's a lot of stuff that's accessible to understand that. It's
super flexible. It's nice. If you want to give it more specificity and actually define which colors are which, because in this case, I think downstream is pink and midstream is blue and upstream is orange. If we wanted to flip that, we could just explicitly tell R, I want upstream to be hot pink, midstream to be royal blue, etc. And now it's what we want it to be. So that's a nice way. Similar to what we did before with our theme information, how we define that as a variable, we can do the same thing with our colors, which just helps clean up the code a bit. So I defined it as my colors, and in that scale color manual function, now it just looks a bit cleaner. So it's nice. That's what I have for colors and changing your theme. I'll get into now making your plot just look a little bit better overall. So changing the size of your points is very simple. We go back to this geom_point command, and that's where we're going to do every edit we want with our points. We'll change the size of it there. A little bit easier to see now, which is nice. If we wanted to add labels to the points, this is sometimes nice in identifying outliers. So in this case, I'd say maybe upstream 42. It's been given a name now. It's a little bit out of the way from the rest of the crowd, so maybe it's an outlier, but maybe it's not. It's just a nice way of identifying. If you also wanted to label your points, you can just stop there. Now, if we look back at the auto plot, it gave us the variation of everything is explained. There's a way to figure out how to call that in and just do it automatically, but I haven't figured that out yet. So I just refer back to the auto plot and I steal that value from that. And you can use the XLab and YLab to define what you want your labels to be called. So I just added in the 72.77 and 23.03. It just makes your PCA more informative. And then what I think a lot of us like to have is ellipses. So if we use the stat ellipse command, we'll let it know that it's a polygon geometry point, and our aesthetics, we're going to have it filled by location. So we're going to mimic the colors from our locations. Alpha is just let it know that we're going to make it more transparent, and the size is actually referring to the thickness of the border. So if we made the size 5, it'd give us really thick borders. I think you can also change the line type as well if that's something that you want to do. And if we wanted to make the alpha really small, it's barely noticeable. So there's lots of flexibility in ways you want to change things. Also, sometimes when you're making a PCA, you like to have the loadings, and those are those biplots, those little arrows that point out and let you know what's driving everything. So we can define the loadings by going back into our PCA variable that we saved and pulling out the rotation information. That's just how R saves your loadings plot information. So once you've added in your loadings, you can then use the geom segment, and that will, just following this command, it just defines everything. And you can pull up what your arrows are. That's nice, but it's not super informative just because we don't have the text associated with it. So giving names to these arrows, we just use the, that's where ggRepel comes in. if you annotated this normally with just the text, you might have some overlap. That's where ggRepel is really nice because it won't have things overlap. So we'll just see what that looks like. Yeah, so it's overlapped a little bit, but I'll show a workaround afterwards. But now everything is labeled, so we can see it looks like the higher fork lengths and everything is associated with the midstream and downstream. So the upstream is markedly different from the remainder sites, and our Mercury content is also somewhat driving the upstream sites into their positions. So it's interesting. I don't think it really makes much sense because I just made up these variables, but anyway. And also when you're making a PCA, sometimes it's also nice to have the markations of the grids. So I just like to have the 0 lines markated so you can just see like there's the center where those arrows are coming from. And if you just notice between this code and the previous code, I put the H line and V line before the rest of it because when you're doing your ggplot, it's going to call everything out in the order that you laid it out in, if that makes sense. So if we zoom in, I don't know how well this will show it up, but you can see that the arrows are on top of the ellipse and the ellipses are on top of the, like that crosshair on the zeros. And that's because our geom segments are on top of our ellipses, but our ellipses are on top of the geom H line and V line. I don't think it really matters for everything else. It's just more so for those lines that we added in. Another thing too is we can change the names of our, what do you call that? Our legend. So that's done in the scale color function. We had to do that for both the color fill and the scale manual fill and the scale color fill, because if we did just one, let's see if I took out, so we added in the name function location. I think it would give us a separate one. So if you just did it in the one, it would take it as a separate one because there's in the legend axis or in the legend element, there's actually multiple components. There's like the outlines, there's the fill, and that also applies with like your alpha levels or how transparent it are. So you have to make sure that you apply everything to each of those so that it gives you just one legend. And also just to make your plot look a little bit better, if you want, you can add in a, what do you call these, like the breakpoints in your axes. So before it went up to, I think, -2 and -2.5, which is nice. But if you want to give more precision or just define it for whatever reason, you can add in the breakpoints that way. So that's just by doing the scale X continuous and scale Y continuous. Lets it know how, like what your limits are and what they're going to be broken up by. So by ones, if we did it by 0.5, we'd see now that it's going to give us even more divisions, but that gets a little bit cluttered. So we'll just leave it as 1. And so I'm pretty happy with how this looks. I'd say that this is good and we can save it. One way that you can save it is the export function. That's just going over to the plot window and clicking on export and save it as an image or a PDF. You get a bit of a preview and you can change the width and height of it, but I'll just show you what this looks like. I don't do this because, let's see, there's the test image. If you save it like this through RStudio, it's fine if you're doing a quick and dirty plot, but if you want to save this at a better resolution, like automatically this just looks really bad. Like you can see all the pixels and you know that it looks better than that, so we're going to do something different. Just like before with our loadings and our data and our colors and our theme, we're going to save this whole ggplot as a variable. So we'll just label it as PCA. And if we clear out all these plots here, you'll notice that when I save it as a PCA, nothing pops up in that window. That's because we have to call this variable now. Once we call the PCA variable, it'll pop up. So that's just another way of working with it. And you can use the Ggsave function. You just give it a name. Make sure that you give it the file extension that you want it to be. So SVG or PNG, JPEG. I recommend PNGs or SVGs because PNGs will give you the transparency that you're looking for, and SVGs will let you modify it later on. Make sure you let it know what the variable is that it's going to be saving it from. Define the width, the height, and as well the inches or the units that it's going to be used in. And what's really nice is you can save it at a certain dots per square inch or whatever that DPI stands for. So I usually just go with 600 because why not? And it saves it. So it's super nice. And you'll notice that like the overlap of the labels on these arrows isn't the greatest. So once it's saved as an SVG file, you can open it up in Inkscape, which is another program that you can install if you want to. It's not necessary, but I use it all the time. It's an open source answer to one of the Adobe programs. Hopefully it opens quickly for us. Yeah. So this is Inkscape. And when you're using this, don't move, of course it's going to open multiple. Don't move any of your points because that's going to completely ruin your graph. If you move this point up here, all the way over there, like that's just dishonest and you've, I don't know, it's not a huge difference, but you shouldn't be doing that with your data. I don't expect any of us to do that, but I'd use this primarily just to move all of your points, all your labels and things like that, just to make things look nice because it's just way simpler than messing around with the code sometimes just to go in and do it manually, especially if it's just for labels. So once I'm happy with that, I can just go over to File and save it as, oops, that's going to save the SVG, but you can export it as a PNG. So we'll export that. Oops. And I don't know if it saved it properly, but yeah. So, and there we go. So that's our beautiful PCA that we worked so hard on in R. Yeah, are there any questions on that?
That was really great, David. That was really, really great.
That was really helpful. Thank you, David.
Yeah, you're welcome, guys. If you guys are around for 2 more minutes, I can show you something else. This just saves like my sanity when I'm making PCAs or CCAs or RDAs, like more of those ordination plots. It's a program called Past. Past is used just to make ordinations and other types of univariate, multivariate analyses. It's kind of close to Excel in some ways, but you can't really do a lot of manipulation. So the one thing about PCAs is that all of your points have to be center standardized to reduce the weight of different units of measurement. So you have to do that in Excel first.
David?
Yeah.
Do you think you can use the, you think you can download the normalized data from MetaboAnalyst? Like if you just use MetaboAnalyst to normalize it, then download that data sheet and then use that instead, or no?
For making a PCA?
No, like you know how you're normalizing your data because you want to have it more centered so it's not like all over the place because of the units. Can you do that on MetaboAnalyst and then use that downloaded normalized data for this, for whatever you're doing right now, instead of doing it all in Excel?
You might be able to. I don't know. I don't know what the way is that it's normalizing your data. From what I understand, PCAs, you don't, like you're only normalizing it just to reduce the weights of things and make everything on the same scale. When you normalize it in MetaboAnalyst, I think it's making it look more like of a normal distribution, and you're not always going to have normal distributions with your data. And I think you don't want to do that. You just basically want to have, I'm assuming you'd probably do this with your proteins. You'd have your list of proteins and just have them as they came out of spectra, I believe.
Oh, okay.
Yeah, because in the R script, there's a command when we're making our principal components that lets it know that we want it to be centered and we want it to be standardized. So that's why we don't have to do that for the R script. Does that make sense?
Yeah.
Okay. I'll run through this really quickly, but if you guys want me to go into more detail, I can tell you afterwards. For past, you just lay out all your data, and I just open up another tab. When you're center standardizing it, all you need to do is get your average of your first column. So this is the average here, and your standard deviation. And then you just take every point and you subtract the average and you divide it by the standard deviation. That's how you standardize all of your data. And to know that you've done it correctly, if you do an average of what you just did, it should equal 1, I believe. It'll be close to 0, and then if you do your standard deviation of all these, it should equal 0. That's just a way to check. I only use past just to make sure that I'm not going crazy. Sometimes I just feel like, oops. Yeah, I just wanted to be double checking everything basically. So once you have all this information, all of your center standardized data, throw it into past by editing like your row attributes. Like this just lets you edit everything. Highlight everything using that little button there, multivariate, ordination, principal components. And this gives us some information, but more importantly, it gives us our scatter plot. And this just lets me know that what I developed in R, like with the auto plot function and just even doing it manually, it looks like how it's supposed to run. So this is just really a backup just to confirm that your PCA looks how it should. So comparatively, they look the same. Of course, the proportions are a little bit different, but everything looks good. So that's another quick program to use.